Alright, this is a review of section 1.5, factoring and combining like terms. So I'll notice a lot of you guys are having trouble factoring, and so watching this video might help you refresh your memory on how to factor. First of all, we'll have an expression 2x plus 4xy. We want to factor out the common terms in here. Alright? Now first thing first, I always go by circling the numbers. When I see the numbers, I'm going to circle the numbers. The numbers are 2 and 4. What are the common factor for 2 and 4? Well, if you can't think of it on top of your head, go ahead and find the numbers that divide into 2. 1 divides into 2, 2 divides into 2, and that's it, right? What about 4? 1 divides into 4, 2 divides into 4. 3? No, 3 does not divide into 4. What about 4? Yeah, 4 divides into 4. So now we look at the common factor, right? The common factor would be 2, correct? So 2 would be a common factor for just the numbers. Now we look at the variables. I am going to go ahead and underline the variables. Here on the first term with the variable x. In the second term, we have the variable xy. Now, when we try to factor out the terms, we gotta make sure that this term that we're factoring out has to be a common term, a common variable that these two terms share. And these two terms does share one common variable, and that is x. And we can take out 1x because both of these terms has exactly 1x. So now our common factor is 2x. After we have a common factor, we leave our common factor outside of the parentheses. We just draw a parentheses right next to it. And now we've asked ourselves, what did I multiply with 2x to get to 2x? Well, 2x times 1 is equal to 2x. We keep the sign, plus plus. What did I multiply the 2x to get to 4xy? The answer is 2y. Now, if you want to check if your factor form is correct, go ahead and multiply 2x and distribute it back into the parentheses. 2x times 1 is 2x. 2x times 2y is 4xy. Okay? It's the same thing. It's the same thing. Okay? Check your answer. Now, we're going to do a separate example, a different example now. We have the example of 3x cubed plus 6x squared plus 9xy. Again, we circle the numbers in each term. 3, 6, and 9. We circle the numbers in front of the variable, not the exponent, okay? Just the number on top of the variable. Now, what are the common factor for 3, 6, and 9? Well, the common factor for 3, 6, and 9 is just 3. Now we look at the individual variable from each term. We got x cubed, x squared, and xy. What do each of the variables in each term share in common? What do they have in common? Well, they all share an x, right? So we can factor out an x. But the question remains, how many x can we factor out? Well, the rule is if we factor out 1x here, we have to factor out exactly 1x here and here. If we factor out 2x here, we have to factor out 2x here and 2x here. So you have to make sure that it's consistent across each and every term. Well, we can only factor out 1x here because notice that the third term only has 1x. Doesn't matter right here, we have 3x multiplied together, 2x multiplied together. We can only factor out 1x because there isn't 2 x's to take out from here, neither is there 3 x's to take out from the last term, right? So then our common factor for all three terms would just be 3x. Again, we draw the parentheses next to our common factor. 3x times what gives you back to 3x squared? The answer is x squared. 3x times what gives you 6x squared? Answer is 2x. 3x times what gives you 9xy? The answer is 3y. Okay? So these things are just, they come naturally as you practice more and more. It doesn't happen overnight, but with more practice, it does happen. So there you go, that's your factor form. Now we move on to combining like terms. I know this is something that we have not gone over in class yet, but we will. So let's just give you an example, a quick example. If I have the example of 2x plus 5x, and that just asking if I have 2 x's and I'm adding 5 more x's, I have a total of 7 x's, right? Now let's get a little more complex. If I have 2x squared plus 4xy plus 3x squared minus 2xy, right? I don't know if you guys can see. Let's see. What would the answer be? Now, don't confuse yourself just because you see a variable with exponents and you see it x, y, and you start freaking out. Don't freak out, okay? It'll be okay. Now, the easier way to remember how to combine like terms is to associate the x squared. You see that this is an x squared. We also have an x squared here. So think of x squared as something, maybe like basketball. Let's say x squared is basketball, right? Basketball. And now we have another term with different set of variables, x, y, right? Here again we have x, y here. So maybe think of them as frisbee. Maybe I should have used a food example. I'm quite hungry right now. But that's okay. So we have basketball as x squared. And xy we represent it as frisbee. Okay? So if I have 2 basketball, right? 2x squared. Now we associate x squared as basketball. If I have 2 basketball plus another 3 basketball, how many basketball will I have? I'll have exactly 5 basketball. If I have 4 frisbee, take away 2 frisbee, I will have 2 frisbee. And there you have it, ladies and gentlemen. This is combining like terms. I hope you enjoyed the video. I'll see you in class. Bye.